we have no mode. Next, we have the median. So the median is the middle value of a distribution. It divides the data into two equal groups. So we can say that you have the lower set, so these are the persons who get lower than median, and then you have the upper set, so the persons who get higher than the median. So you can divide it in two equal groups. Then we have the weighted average. This is an average based on the relative importance of each component. So this is basically how you get your statistics grade. It's based on a weighted average. The first mid-semester is 25%. The second mid-semester is 25%. Then your finals is 50%. So your grade is based on a weighted average. I don't remember what a weighted average is, just remember how you normally get your grades. So for any subject that you're doing, it's normally based on a weighted average. So the last thing we're going to look on in our sums is our S, which has to do with spread. So the spread as the width of the distribution. It is used to measure if numbers in a distribution are close together or spread far apart. So there are four that we will look at. So we have the range, the variance, the standard deviation, and the interquartile range. So the range is the simplest one. So it's a simplest measure. We normally get the range from the maximum value minus the minimum value. That's just the range. So the range normally uses outliers. Remember, an outlier can either be at the beginning or at the end of your data set. So that means that your range normally uses outliers. So in other words, your range is the largest value minus the smallest value. All right, now we're looking at the variance and standard deviation. So once you calculate a variance, you can always get a standard deviation because your standard deviation is just the square root of your variance. So the variance measures the spread of the distribution, and the standard deviation is a positive square root of the variance. The standard deviation is not a resistance measure. What does that mean? It means that your outliers should not affect your standard deviation to an extent. So now we're going to look at the 5-number summary. So the 5-number summary is a box plot. It's a graphical representation. The box plot, which is here, is a graphical representation of the 5-number summary. So we have the maximum value, the minimum value, then we have our interquartile ranges, we have our upper quartile, which is normally Q3, we have our median, which is normally Q2, and then we have our lower quartile, which is normally Q1. So as you can see, the minimum is normally in the 0th percentile. The lower quartile is in the 25th percentile. The median is the 50th percentile. Remember that it divides your data set into two. Upper quartile is normally in the 75th percentile, and then the maximum is normally in the 100th percentile. Remember that we normally use a 5-number summary when we have outliers. So when we know for sure that the data is going to be skewed. So when to use what? So the 5-number summary, we normally use the median and the interquartile range to describe it. So it's better for skew distribution or if you have outliers. Then for the mean and standard deviation, it's better for symmetric distribution without outliers. And remember that for it to be symmetric, everything has to be equal. The mean, the mode, and the median has to be equal. Therefore, there are no outliers. All right, so let's do a question. A certain brand of bean is made so that each package contains about the same number of beans. The filling procedure is not perfect. However, the packages are filled with an average of 375 beans, which is normally distributed with a standard deviation of 8. Yesterday, Kadian went to the store and purchased 4 of these packages. Out of curiosity, she counted the number of beans in these packages. Her 4 bags contain an average of 382 beans. What is the above scenario? Which of the following, in the above scenario, which of the following is a parameter? Which of the following would be a parameter, guys? Yeah, the exam is multiple choice. The exam will be multiple choice. So yeah, so in the above scenario, which of the following is a parameter would be the average number of beans in all package made is 375. Remember that when we're dealing with remember that a parameter is the value of our population. And because it says that the packages are filled with an average of 375 beans, which is normally distributed with a standard deviation of 8, we know that the average number of beans in all package made is 375. It should be 375, but you know, we're humans, we make error. But the parameter, which is a value, the numerical value of our population in this case would be that the average number of beans in all packages made is 375, because they did tell us up here. It says that if you went to the store and purchased 6 bags of this brand of bean, what's the probability that the average number of beans in your bags is less than 373? So I worked this out for us. So we know that our N in this, our sample size in this case would be 6. We know that based on the question before that our standard deviation is 8. So which is normally distributed with a standard deviation of 8. And our population mean is 375. Based on here, the average, the package are filled with an average of 375 mean. So they wanted us to find the probability that the average number of beans in your bag is less than 373. We know that when they ask about average, we're dealing with the sampling distribution about the mean. So we can write our probability statement that the probability that X bar, because we're dealing with the sampling distribution, that X bar is less than 373, which is equal to X bar minus mu divided by our standard deviation divided by the square root of n. So it's equal to 373 minus 375 divided by 8, which is our standard deviation, divided by the square root of 6, which is equal to negative 2 divided by 3.266, which is equal to negative 0.61. We could go into our normal distribution table or negative normal distribution table. The value that we had was negative 0.61. So the value is going to be 0.2709. So this is our value. So the answer is the probability that Z is less than negative 0.61 is equal to 0.2709. Therefore, answer would be A. You guys have any questions? Any question, guys? Are you guys all good?
Can you please repeat what the n equals 6 means?
The n equals 6 is from the question. It says that if you went to the store and purchased 6 bags of this brand of bean, so in this case, our sample size is going to be 6. Because that's the amount that we purchased. This question would have been in unit 4, but because question 13 because question 12 and 13 are done together, I could not separate them. So this is from our sampling distribution of the mean. So the question is based on the sampling distribution of the mean, which would come from unit 4, but I just worked it here so that we could follow. But I don't think so. As I said, I did this presentation based on Miss practice package. So anything she asks in the practice package, that's what I did. And based on previous papers, she normally asks, she's basically going to ask you like, so remember like when to use what? So maybe she'll give you a graph and then she says to you, what would you use? You know that if the graph has an outlier,